Okay, sorry, I self-muted. I was censoring myself even before the start of the talk. Okay, can you see my slides? Thumbs up if you see my slides. Great, thank you. Okay, well, first of all, I'd like to thank John, Mark, and Thomas for organizing such a wonderful series of online events and for inviting me to be a part of this event series. And the topic I'm going to talk about today is part of a broader ERC project grant awarded to Nick Shea within the European Union Horizon 2020 Research and Innovation Program Agreement 681422. And this research project concerns relation between metacognition on one hand and concepts on the other. And my talk today is going to be big picture talk. So I'm not going to go into the details of the account, but of course, this is something we can discuss during the Q&A. And if you're interested in having some background and in reading more about the empirical data I used in this project and the literature review about the evidence there is on this topic, I invite you to check the paper we co-wrote with Nick Shea, which is available in open access in the Review of Philosophy and Psychology. So as I just said, the broad aim is to understand relation between metacognition and conceptual change. And of course, the big background question, which is, of course, of central interest of both philosophers and cognitive science, is how do we change our concepts? How do we revise our concepts? How do we acquire new concepts? How do we enrich existing concepts, or how we abandon concepts that became in some sense defective? And of course, this is such a big issue. So one way of trying to answer this question is to explore the role of some cognitive processing in a process of conceptual change. So the broad aim of my talk is to explore the role of metacognition in conceptual change during infancy. And whereas the focus here is on development and on children's development, one of the future directions of the project is to explore the same issues, but for adults. But for reasons you will see later on in my talk, infant development might be a crucial stepping stone toward understanding the role of metacognition in conceptual change. And as I said, this is a big picture talk. And within this broader issue, in the next half an hour, I want to, to reach two specific goals. So the first specific goal of my talk is to suggest that different types of metacognition have different roles in conceptual change. And the second goal of my talk is to propose a suggestion that is that changes and developments in procedural metacognition could kickstart a new stage of conceptual change in infants at ages that are rather young, so younger than for the other type of metacognition, but I'm going to talk about this in a bit more detail later on. All right, so my talk will unfold in 4 parts. I will first introduce the phenomenon of conceptual change. Then I will sketch the distinction between different types of metacognition, and particularly between analytic metacognition on one hand and procedural metacognition on the other. Then I will briefly outline one role of analytic metacognition in conceptual change. And in the last part of my talk, I will mostly focus on exploring the possible roles of procedural metacognition in conceptual change. Okay, let's start with conceptual change. So to be honest, when we think about conceptual change and we talk about this notion, they're really talking about a very broad family of different views and theories. So I'm going to cheat a little bit, and I'm not going to define what conceptual change is. I will rather introduce conceptual change by some examples. But of course, you can pressure me about conceptual change in the Q&A if you're more interested in this issue. So when they initially think about conceptual change, some of the most important discussion of this notion come from history of science. So following Thomas Kuhn's seminal work on scientific revolutions and paradigm changes, historians and philosophers of science focused on the question of how do groups of experts revise their scientific concepts and scientific theories. And one example of such a research is in Nersessian's book about conceptual change, where she really focuses on the most creative and striking dimensions of scientific practice. So the examples of conceptual change she's interested in are, for instance, Mendel's notion of gene, Newton's notion of gravity, Maxwell's notions of field, Einstein's notion of space-time. Similarly, Taggart calls his book Conceptual Revolutions, and he's really interested in the big scientific revolutions such as the Darwinian Revolution, the chemical revolution triggered by Lavoisier, the quantum theory revolution, and so on. But there are types of conceptual changes that are not at the level of a group of experts, but they're rather at the level of the individual. So conceptual change is not limited to these topical examples involving groups of experts, because individuals also undergo conceptual change. And especially children during their development, so from birth up to the end of schooling, they undergo profound conceptual changes in their theories and beliefs about the world, especially when they start school. And some of these changes are, in a certain sense, revolutionary. So some changes in infants ontogenetically recapitulate the scientific revolutions of history of science. For example, when a child switches from a concept of Earth as being flat and the sun rotating around the Earth to a concept of Earth as being an astrological body, which is round and which rotates around the sun. But some other changes in concept in infants could be more mundane and not revolutionary. For example, when they add or subtract some information from an already existing concept. So in what follows, I'm going to present you 3 examples that come from the developmental psychology of conceptual change. And these examples might strike you as more or less clear cases of conceptual change. But all 3 examples are discussed in this literature, which is a literature at the intersection between developmental psychology, education science, and history of science. So the first example is the concept of living being. So the concept of living being appears really early in development. And the initial concept of living being for young children, to simplify, basically picks up anything that presents some set of perceptual cues for an imacy. For example, self-propelled motion or goal-directedness, equifinality of paths toward an outcome. And as a result, it integrates, it picks up entities in the category that are actually not living beings. For example, a car or a self-driving car, or this self-moving vacuum cleaner thing called Roomba. They are all categorized as being living beings on the basis of perceptual cues, while plants are not. But in the process of development, and there are many theories about how it happens, children understand that not all self-propelled entities are living beings, and not all not self-propelled entities are actually also living beings, for example, plants. So slowly their concept of a living being evolves, and it also includes plants as part of the extension of the concept. So the second example comes from the study of children's naive physics. And in the case of discussed by Annette Camilo-Smith, the study of naive physics in infants comes in the form of the understanding of the laws of torque involved in balancing bricks. So by the age of 6 or 7, children have learned a rule for how to balance bricks, for how to solve the task of balancing bricks. And interestingly, they stick to the rule even when the rule fails. So in the experiment Annette Carmel-Smith talks about, they gave children bricks that are asymmetrically weighted. So their center of gravity is off balance. And at the age of 6 or 7, children apply the rule despite seeing that this rule is failing in this case. So it is only by the age of 8 or 9 that they learn from experience about the rule's limitation, and then they acquire a more comprehensive concept of balancing. And the third example concerns a case of what we could call conceptual differentiation. So here an undifferentiated concept of heat/temperature is in the process of explicit teaching and schooling, is split into two concepts. So the concept of heat on one hand, which is the total energy of molecular motion in an object, in a substance, which depends on the size, the type, and the mass of the particles. And the concept of temperature, which is the measure of energy, which does not depend on the size and type of object. So for example, cup of water has the same temperature as a bath tube full of water, but of course the bath tube full of water has more heat because it has more particles and more thermal energy. And this is also a case where, in a certain sense, children's development recapitulates history of science, because the distinction between heat and temperature wasn't made until mid-18th century. Okay. As I said, these are just examples. So I haven't defined conceptual change so far. And as I said, I'm not going to define it in this talk. What I'm going to do is to just outline the type of questions we could ask about conceptual change. And one question is really about how many types of conceptual change there are. And when I'm talking about types of conceptual change, I'm actually including in this talk concept acquisition, concept revision, splitting concepts, and enrichment, even though I'm aware that the type of processes involved in concept acquisition might be different from enrichment, split, and revision. And in particular, we could ask the question of what counts as a change of concept versus what counts as a change in a concept. Or to borrow terms from Kuhn, what counts as normal concept and what counts as a paradigm shift in conceptual revision. And of course, this connects to a very broad background question, which is the question of what concepts are, what is a concept, and how it is structured, if it is structured, which is something that we might talk about in the Q&A. And another question we could ask, which I'm going to touch upon a little bit at the end of my talk, is why it is so difficult to revise some concepts. So it is difficult for children, especially, but also some adults have a very hard time to revise their concepts because they tend to stick to some concepts during their adult lives, as the image I'm using here suggests. And in a process of conceptual change, of course, many different factors are involved. And some of these factors are cognitive, so they belong to the individual's cognitive systems and cognition. And other factors are sociocultural and contextual. So my aim here is, of course, not to simplify a process of conceptual change to just one factor. It is rather to grant that there are many factors involved in a process of conceptual change and explore only one of them. And the factor I'm going to explore is metacognition. So metacognition is sometimes defined as thinking about thinking, but this is not entirely exact. So a better definition of metacognition is by its functional role in cognition. And its functional role is to be the set of processes that monitor and control cognitive activity, where cognitive activity includes basically any type of activity you can think about: perceiving, planning, categorizing, remembering, learning, desiring, intending, and so on. So monitoring refers to the processes involved in the supervision of cognitive activities while they unfold. and in evaluating their progress and success in respect to the goal of a specific task. Control refers to the top-down management and regulation of cognitive processes that could make use of feedback from monitoring the goals of a person and of her background beliefs and theories about cognitive processes in question and her own abilities. So actually, I think that in 4 weeks' time, you're going to hear a talk from Joël Proust, whom I've seen appear on Zoom. So you're going to have a much more detailed presentation of what metacognition is and of the different types of metacognition that we have. So I'm just going to sketch briefly here. The distinction is between analytic metacognition on one hand and procedural metacognition on the other. And analytic metacognition encompasses explicit beliefs about first-order mental states and processes, for example, about effective memory strategies. And it is meta-representational. It uses concepts and folk beliefs, such as naive theories about how mind works. It is later developing. It is plausibly not shared with non-human animals and preverbal babies. And since analytic metacognition draws on people's folk beliefs about how mind works, these folk beliefs can actually be false. Procedural metacognition, on the other hand, is based on feelings attached to cognitive processes, like a feeling of fluency during recall, or a feeling of knowing when considering a question, such as what is the capital of the UK? So procedural metacognition is a non-meta-representational kind of informational self-evaluation, so whose function is to control, monitor first-order cognition. So as I just said, procedural metacognition is non-meta-representational, so it doesn't require representations of representations to unfold. It uses feelings attached to cognitive processes. It is plausibly shared with non-human animals and preverbal babies. And signatures of metacognitive processes have been found in infants as young as 12 and 18 months old. Now, of course, I'm not saying that these two processes are completely separated, and the relation between the two is extremely complicated. So I am simplifying the picture a little bit. But what's interesting for us is that metacognitive feelings can be based on conscious experiences, and the conscious experiences can be used either to directly control behavior or to formulate judgment based on the conscious experience. But of course, with judgment that are formulated based on the conscious experience might also appeal to other factors. And a striking example of this comes from research on the feeling of fluency and disfluency. So in some cases, a feeling of fluency or disfluency can be used to formulate a judgment of accuracy. For example, when the trust or the judge as being more accurate text, which is written in a more fluent font versus a text which is written in a disfluent font. Okay, having introduced the two main notions I'm interested in, I want to argue in what follows that the role of analytic metacognition is especially connected to reflection and explicit reasoning. And its distinctive role consists in the understanding of the processes involved in conceptual change. One example of such a role comes from the use of analogies for changing concepts. Now, analogies involve two concepts, usually from different domains, and a mapping between these two concepts, but without a combination or integration of the two concepts. Using an analogy per se does not require metacognition, and there are spontaneous uses of analogy that are not metacognitive in nature. But what's interesting is that there's some research in educational literature showing that unreflective analogy use can be detrimental to conceptual change instead of fostering it, especially if the analogy reinforces the starting conceptual point rather than helping the thinker to overcome it. So this is where analytic metacognition actually can come to rescue. And indeed, the reflective use of analogies in learning is usually explicitly taught in an educational setting. And it makes use of metacognitive strategies, such as understanding how one conceptualizes a domain and grasping the educational goal and purpose of analogy in explaining a phenomenon. So you can see in the slide, it's a reference to a study done by Lucia Amazon in Padua, which describes the way children use an analogy with the postal system to learn a sophisticated conception of blood circulation at 10 years old. And Lucia Amazon found a high correlation between an understanding of analogy and a metacognitive awareness of analogy's meaning and purpose in a process of conceptual change. So children who metacognitively understood the analogy learned better than children that just unreflectively applied the analogy without a metacognitive, metaconceptual awareness. And in general, children from 10 years of age, when using an analogy to revise an old concept, appear to be using explicit metacognitive considerations to understand the nature and the instructional purpose of analogy. And they think explicitly about ways in which they themselves conceptualize the starting concept, and they explicitly conceptualize the way in which the initial concept can be compared to the other domain, what is used as a learning prop. And they apply this with reflection and metacognitive awareness. And indeed, the educational literature on conceptual change has focused a lot on analytic metacognition and its role in fostering conceptual change and conceptual revision. But the question I'd like to ask now in the final part of my talk is, does every role of metacognition conceptual change require reflection? Is there a role for metacognitive feelings in a process of conceptual change? And I think that the focus of analytic metacognition in the literature on conceptual change has left a gap in the role of procedural metacognition in changing concepts. In fact, using analogies, and especially using them well and understanding them, requires sophisticated metacognitive abilities. But there might be a role for metacognition that doesn't appeal to these sophisticated metacognitive abilities. And what's interesting is that the literature on learning in general has focused on both analytic metacognition and procedural metacognition, but not the literature on conceptual change, or at least not as much. So what I'm interested in is to fill this gap. So to fill the gap between the existence of procedural metacognition and its role in some cases, or maybe in all cases, of conceptual change. Okay. So to approach this question, the first thing to note is that, as I mentioned in the second part of the talk, procedural metacognition develops much earlier, or at least earlier than analytic metacognition. And this opens up the possibility that it might be involved in the early stages of conceptual change rather than in the late stages of conceptual development and change. And the question I would like to ask is, are there developmental changes in procedural metacognition that could have a whole-scale effect on the way children acquire new concepts, revise their old concepts, and maybe replace existing ones? So, okay, so I want to apologize for such a charged slide. I know that it's a bit difficult to read. So what this slide sums up is, very briefly, it sums up the developmental path of procedural metacognition and how feelings can be used for formulating judgments and the developmental path of the judgments. So as I already mentioned, procedural metacognition is observed in infants in the form of confidence or uncertainty monitoring. And so at 20-month-old, infants can ask for help in a memory task already. By 2 years old, children are monitoring their own state of knowledge or ignorance, and they can communicate it verbally or non-verbally, and they use it as a basis for asking for more information. And skipping ahead in the future with older children, what's interesting is that there is a developmental trend for judgment based on metacognitive experiences, on feelings. And this is the case, for example, of judgments of confidence. Where judgments of confidence is the estimation of the correctness of one's knowledge. And the accuracy of trial-by-trial cognitive judgment is initially low, especially in preschool years where it is characterized by overconfidence. But it becomes more accurate with development, so that by the age of 7 or 8, infants can accurately report whether an answer is likely to be correct or not. In the case of judgments of learning, which are judgments about how well one has learned a certain piece of information, and judgments of learning are used a lot in metacognitive research on memory, they also show a trend toward better calibration between the ages of 6 and the ages of 12. Preschoolers' errors are in the direction of overconfidence. So they are overconfident, they're making a prediction about how well they will recall items in the future. But there is a marked change toward better calibration in the first years of school. Until at 12 years old, their judgments of learning are more or less similar to the judgments of learning made by adults. So we can see that there is a certain developmental trend in judgment based on feelings and on experiences in procedural metacognition that suggests that preschool children exhibit generalized overconfidence, even in face of this confirming evidence. So the question now is, what would be the role of a feeling of confidence in conceptual change? And as I said before, it's a question that hasn't been explored so much. So of course, there are some studies about this question, but I think it's a question that could benefit from an in-depth exploration. And we have some data by Van Loon and colleagues about the impact of overconfidence in concept learning. So it's not concept provision, it's concept learning. So of course, as I said, we can discuss during the Q&A whether concept learning, concept provision require a similar type of processes. So when learning a new concept, 8-year-old children are overconfident in their judgments of learning, regardless of ability to generate new sentences containing this new concept. Older children also show some tendency to overconfidence, but they are better calibrated than younger children. In any case, the presence of overconfidence in infants' monitoring of concept learning leads to less study time, which in turn has a detrimental impact on mastering of concepts. Now, this is about concept learning. And the question is, what about concept through vision or conceptual change per se? And recall the example of children's concept of balancing that has been studied by Annette Camilo-Smith. So at around the age of 6 or 7, they have learned a systematic rule that they apply even when the rule fails in the case of asymmetrically weighted bricks. And it seems that they are sticking to their concept and to the into the existing concept of balancing. So they are overconfident probably in the existing concept of balancing. It is only by the age of 8 or 9 that children learn from experience about rules imitation and revise their concept of balancing with these limitations in mind. And by this age, so 8 or 9, in general, children's overconfidence starts to be reduced. And their confident judgments about task performance start to reach near adult level consistency. So the speculation here is that when the child already has a functioning concept in a certain domain, the generalized overconfidence could present an obstacle to changing it, even when new evidence is provided. And this leads to resistance to conceptual change. And this suggests that a period of disequilibration is needed so that the children is able to calibrate its confidence levels, and calibrating the children's confidence level might lead to an overcoming of this resistance to conceptual change. And in a certain sense, the feeling of confidence can act as an obstacle, as a cognitive obstacle to revising and changing concepts. And a metacognitive development such that the child is better able to recognize inconsistencies and reduce their confidence as a result might be an important gateway to conceptual change. Well, as you have seen, to gain a new concept for sure, but also maybe to supplement, to enrich, or to replace a defective concept. And the suggestion then is that developmental change in procedural metacognition away from overconfidence and toward reasonably accurate metacognition by the age of 7 or 8 might be an essential precursor to the kinds of conceptual change that depend upon metacognitive disequilibration, that is, the detection of persistent inconsistency. But of course, this raises several questions. For example, what is needed for better calibration? Is it just minimal task experience, or is it a very long and difficult developmental trend? And this connects to the question of what are the mechanisms of overconfidence reduction, and also to the question of, well, is there maybe a positive aspect of our confidence that we might not see in a process of conceptual change, but we might see in our cognitive processes? Okay, so to sum up, I have introduced 2 ideas in this talk. The first idea is it is not only analytic, but also procedural metacognition that could play a role in conceptual change. And the second idea is that analytic metacognition can play a role in explicitly guiding a process of conceptual change, as an example, analogy use, whereas procedural metacognition in the early school years might underscore some resistance to change. But a development in procedural metacognition might have an across-the-board effect on the way in which concepts are revised. So one prediction of this proposal is that variations in confidence calibration might have or will have an impact on the success or the rate of conceptual change. And another question that I don't have an answer here, but of course you also know a lot of evidence about generalized overconfidence for adults. And one issue is, why do adults tend to be overconfident even when actually they are supposed to be better calibrated because they have seen a developmental trend in infants? And the second question is, does overconfidence plays any role in adults' resistance to conceptual change? But I don't have any answer to this question so far. So this is the account I have sketched so far. Metacognition can play a role in conceptual change, and different types of metacognition can play different roles in conceptual change. So I thank you for your attention, and I'm looking forward to hearing your thoughts.
Thank you. Everybody give a virtual clap.